Today I'm going to talk about different types of chemical reactions. There are 5 different types of chemical reactions that we talk about in pre-AP chemistry and regular chemistry for that matter. For the 5 different types of chemical reactions, there's synthesis, decomposition, single replacement, double replacement, and combustion. Up on the screen right now, I have some just general overviews of what the different types of reactions look like. The synthesis reaction, the big thing to focus on is your product. You're only going to have one thing there. For decomposition, you only start with one thing. So these are kind of the opposites of one another. What actually happens with the synthesis is you're going to have multiple types of compounds on your reactant side, and you may form one product in the end. The word synthesis is to make, so we're making one thing. Decomposition means that it's breaking apart. So we have our one compound here, and it's breaking apart into multiple components. It could be 2 things, it might be 3, but you're always going to break things down. For your single replacement reaction and your double replacement reaction, with this one you're going to have more than one on your reactant and on your product side. With your single replacement reactions, you're going to have a single element before and after. Double replacement, you actually have 2 compounds before, 2 compounds after. Now, something to mention on any of these, the first 3 that we actually talked about. With your first 3, anytime you have a single element, especially with your single replacement, you might have a diatomic element. Your diatomic elements are considered to be single elements, even though it might be something like H2. Hydrogen is diatomic, or we call them Brinkelhoff in my class. With hydrogen being Brinkelhoff, it gets a 2 after it. We still consider that to be single. So if you have a hydrogen right here, that's still considered to be single replacement. On your combustion reactions, you're always going to have the same general reaction happening. You're going to have some type of a compound. It's going to burn in the presence of oxygen, because if you don't have oxygen, nothing's going to burn. You're going to always make carbon dioxide and water. So these are your only 2 products that you'll ever make for a combustion reaction. So what you're going to do is you're going to look at your problems, and I just pulled a simple assignment out of a textbook. And with the assignment, we're going to look to see what type of reaction we have. For this first one, you have a hydrogen reacting with oxygen, and we're making water. We form one compound in the end, so this is called a synthesis type reaction. Because anytime you have synthesis, you make one compound. Now the next one, we start with one water, and it's breaking apart into oxygen and hydrogen. When this one thing breaks down, you make a decomposition type reaction. Looking at some of the other ones on this page, you have mercury 2 oxide right there. With this one, you start with one compound, it's breaking apart into mercury and oxygen. That's decomp. Let's see, we have hydrogen peroxide here. It's breaking apart into water and oxygen. That's a decomposition reaction also. Now looking at your other types of compounds, oh, I missed one. This one right here, we're making one carbon dioxide. So because we're making one of these formulas here for your carbon dioxide, that's a synthesis reaction. Your single replacement reactions, you have one single element before and you have a single element after your formula. So with this one, we have on number 3, I have zinc, which is single, hydrogen, which is single, which means that this is a single replacement type reaction. And if you notice, your zinc and your hydrogen are just swapping places. When they swap places, your zinc is now paired up with your sulfate, your hydrogen is all by itself. Number 6 down here, I have chlorine, which is a single element, even though it's Brinkelhoff, and bromine here, which is a single element, so that is a single replacement type reaction. On this one, oh, we missed one. I make one compound in the end. If I make one compound, that is called a synthesis type reaction. Now in the next 2, number 8 and number 10, When you look at it, you actually have two compounds before your reaction, and you have two compounds after your reaction. Anytime you have two compounds before and after your reaction, it's a double replacement reaction. What's happening is your silver and your sodium are trading places with one another. So as they trade places with one another, it's a double replacement. Same thing happens here. Your calcium and your hydrogen are swapping partners. That's a double replacement reaction as well. Now this assignment didn't have a combustion type reaction, but in the last video that we just did, we have this reaction right here that we already balanced. That is a good example of a combustion reaction. We have the C3H8. It's reacting with oxygen. You're making carbon dioxide and you're making water. So this one is an example of a combustion reaction because you have a compound reacting with oxygen to make carbon dioxide and water.